Hi kids, if you would go ahead and get your warm-up book, copy this down. My pen tablet is not responding very well, so forgive me when sometimes if I can't quite, if I have to pause a little bit with these drawings, but notice that my equation is in degrees, right? See, my pen is like going crazy. So right away I'm going to label my axes, theta and y. The y units, right? Remember, this is really like taken from the unit circle, so my y values, my sine values, and my cosine values don't have any units on them, but my x-axis, or my horizontal axis, does, and it's in degrees. So I'm going to sketch and label this graph over one turn in degrees, 0 degrees to 360. So my amplitude is 1/2, but my dilation factor is negative. There's really a 1 here, parentheses, minus a 0, and plus 4, which is my d. So right away, I'm going to go to my graph and draw my sinusoidal axis is at y equals 4. Then I'm going to go up a distance of 1/2 and down a distance of 1/2. And I'm going to mark my top of my road and the bottom of my road. And since it looks like I have a low battery, I better plug in, right? Then, since my dilation factor was negative, I'm going to, since my dilation factor was negative and I'm doing cosine, what does that tell me? Cosine starts at a max or a min, and since my dilation factor is negative, it tells me to start at the min. I'm going to label the top of my road 4.5 and the bottom of my road 3.5. I'm going to start at a minimum, go up to the sinusoidal axis, up to the maximum, back down to the sinusoidal axis, and finish at the minimum. Could have spread that out a little bit better, but I'm going to make my sinusoidal curve nice and smooth, and I'm not going to go below my road. Then I'm going to label all of my points. Now remember, I'm starting at 0 degrees and I'm ending at 360 degrees. To figure out my start, my stop, and my quarters, since my phase shift was nothing, 0, I'm going to start at 0, just like all your homework. I'm going to stop after the length of one period, which is 360 degrees. My quarters are the period, 360 degrees divided by 4. which is 90 degrees. Remember, start minus stop gets you your period. 360 degrees minus 0 degrees. That's how you get your period. Always stop minus start. So over here, I start at 0 degrees, comma, minimum, add 90, and I get 90 degrees, comma, sinusoidal axis. Add 90 to 90 and I get 180 degrees, comma, maximum. Add 90 to 180 and I get 270 degrees, comma, sinusoidal axis. Add 90. And I get 360 degrees, comma, minimum. So, to check my grading, for my grading, what do I have? Sinusoidal axis drawn and labeled. 5 points, 1, 2, 3, 4, and 5 points labeled. My axes labeled with the correct degrees and y. I also have the top of my road and the bottom of my road. And I also have the right shape. Okay? So tonight's handout looks a lot like last night's homework, except that today we're going to have the additional phase shift or horizontal shift to consider besides the dilation factor and the sinusoidal axis. So if you would get out your notes, these are the graphing steps that we've taken so far. The first thing when you look at your equation, you should ask about where your sinusoidal axis is, and remember, draw your middle of your road. And when you draw your middle of your road, it's a dashed line and you label it with y equals. Your amplitude is your top and your bottom of your road, right? From your sinusoidal axis, you go up and down your amplitude and label those. Are you graphing in radians or degrees? It doesn't really, these are the most common variables, but the most important thing if you're graphing in degrees is you have to have that degree mark. Are you graphing sine or cosine? Right? For sine, you start on the sinusoidal axis. For cosine, you start at a max or a min, right? Where do you start and stop? Starting and stopping are your street lights, right? Where do you start? Where do you stop? That is what we're going to deal with today. Remember, your maxes and mins and all your sinusoidal hits come from your quarters, and remember your quarters come from your period divided by 4. So this is today. Where do I start and stop? C. The value of C is what we're going to talk about today. So the effect of C. The first equation at the top of here at the top of this slide shows y equals sine x versus y equals sine parentheses x minus pi over 4. I need you to hold with me for a second while I try to start my tablet over again because it's not responding to me. There we go. So the length of one cycle, remember the length of one cycle we talk about from where you start to where you stop, has always been and will continue to be 0, right? Starting at 0 and ending at 2 pi when we're at radians. That's the length of one sine cycle. But that's if I start at 0. So the length of one cycle is 2 pi if you're in radians, or 360 if you're in degrees. After the starting point, how often do you have to label in one cycle? What does that come from? That comes from your quarters. So that's 4 times after start. So notice here is my start, and then I have 1, 2, 3, 4 labels that I have to mark. So there's a distance of 2 pi, how often I have to label, is 4 times. So if I have y equals sine x minus pi over 4, so I have a phase shift, my sinusoidal axis is y equals 0, right? My amplitude is 1. But my c value, which is inside the parentheses, is pi over 4. Now pi over 4, think about pi is 3-ish divided by 4, so that's a little less than 1, right? 4, a little less than 1. This is your start value. Now I normally start a sine curve here, right? At 0, and then I go up. But now, since I want to shift where I start, right? I'm going to start, instead of at 0, I'm taking this value and adding pi over 4. So now I'm going to start at 0 plus pi over 4, which is pi over 4, but still at the y value of 0. Then I have to figure out where I'm going to stop. So where are you going to stop? Well, remember, I'm still going a distance of 2 pi, and when I create my quarters, I still take my 2 pi and divide it by 4, and I'm going to add 2 pi over 4. Right? Now, normally I reduce that to pi over 2, but I'm not going to reduce that to pi over 2 this time. I'm going to leave it as 2 pi over 4. And here's how I'm going to deal with my quarters. I started at pi over 4, and I'm going to add 2 pi over 4. Where does that land me? 3 pi over 4, right? Then I'm going to add 2 pi over 4. What do I get? 5 pi over 4. Repeat. Add 2 pi over 4. And what do you get? Now let's hold on and say, how many times have I done this? right? I started at pi over 4. That's where I'm starting. And I added 1, 2, 3 of my quarters. How many quarters am I supposed to add? 4. So I've got to do one more, right? So 7 pi over 4 plus 2 pi over 4 which equals 9 pi over 4. And that's where I'm going to stop. As I added another quarter, so now I have 1, 2, 3, 4, and stop. So on my graph, I still am the first thing I'm going to do is my sinusoidal axis. Label it y equals 0. I'm going to go up my amplitude, which is 1, down my amplitude, which is 1, draw the top of my road, and the bottom of my road. But instead of starting at 0, 0, I'm going to start at pi over 4, 0. But I'm sine, and my amplitude is positive, so I start, my dilation factor is positive, so I start on the sinusoidal axis, up to the maximum, down to the sinusoidal axis, down to the minimum, and up to the sinusoidal axis. Draw my curve. And label. Start, comma, sinusoidal axis. Add a quarter. Comma, maximum. Add a quarter, which is 2 pi over 4, remember? So 5 pi over 4, comma, sinusoidal axis. Add 2 pi over 4, and I get, what am I at? 3, 5, 7 pi over 4, comma, minimum. Add 2 pi over 4, which is a quarter, and get 9 pi over 4, comma, sinusoidal axis. Now, remember, my start was pi over 4, and my stop was 9 pi over 4. What is 9 pi over 4 minus 1 pi over 4? What do you get? Eight pi over 4, which is 2 pi, which is your period. Okay, so let's do another one. This time I want you to do a cosine, and I want your phase shift this time is not pi over 2, but negative pi over 2, right? Because of that. So once again, my sinusoidal axis is at y equals 0. My amplitude is 1 because my dilation factor is 1. And the 1 is positive. My phase shift is negative pi over 2. So remember, this is where I start. If I start at negative pi over 2, where do I stop? I need to add my period, right? So if I'm starting at negative pi over 2, I need to add the period. My period is 2 pi, but I'm going to call 2 pi 4 pi over 2. So what is negative pi over 2 plus 4 pi over 2? That's where I'm going to stop. Right? If you start at negative 2 pi, that's where you start. Add the period, which is 2 pi. I turned my 2 pi into 4 pi over 2, and I got where I stopped, positive 3 pi over 2. So notice that here is where I'm starting. That's negative pi over 2. I'm going to add two pi, which got me to 3 pi over 2. And then in between here, I'm going to add my quarters. And remember, your quarters are your period divided by 4. So add the quarters to your start. So if you start at negative pi over 2, add a quarter. My quarter is 2 pi over 4. But this time I am going to go ahead and reduce, right? 2 pi over 4 is the same as pi over 2. So I'm going to add pi over 2 and get 0. Add another quarter, which is pi over 2. Add another quarter. Add another quarter. And stop. Go back and make sure. I started at negative pi over 2 and I added 1, 2, 3, 4 quarters to get me to my stop. Since I'm drawing cosine, I know I'm going to start at a max or a min, and since the dilation factor is positive, I'm going to be starting at a max. Label my sinusoidal axis. From your sinusoidal axis, go up a distance of 1 and down a distance of 1. Draw the top of your road and the bottom of your road. Again, forgive my pen being not as cooperative as it could be. Since you're cosine, you're going to start at the max, go down to the sinusoidal axis, go down to the minimum, back to the sinusoidal axis, and finish at the max. And let's label. We're going to label the start point, comma maximum. Add a quarter, sinusoidal axis. Add a quarter, comma minimum. Add a quarter, sinusoidal axis. Add a quarter, comma maximum. Good? Not so bad, right? All right, let's do a combo. So each one of those previous two examples, I have left the dilation factor as 1 and the sinusoidal axis as 0. So for this one, I have changed the dilation factor. Remember, our B is still 1, and I left our sinusoidal axis at 0. So I'm going to go ahead and draw that first. I'm going to draw my sinusoidal axis and label it. I'm going to label my axes, which I think I may have forgotten to do before, right? And my horizontal axes, theta. I am going to go up from my sinusoidal axis and down from my sinusoidal axis. Draw the top of my road and the bottom of my road and label where those are. My dilation factor was -2. My amplitude, remember my amplitude is the absolute value of the dilation factor, which is 2. So I'm going to add 2 and subtract 2, which will land me at 2 and -2. I already took care of my sinusoidal axis. Since B is 1, I know my period is normal, which is 360 degrees. But my phase shift is -45 degrees. So that's where I start. So start at -45 degrees. My quarters are 360 degrees divided by 4, which is 90 degrees. So take your start point and add 90 degrees. That gives me +45. Then add 90 degrees, which is what? 135 degrees. Add 90 degrees, which is what? 225 degrees. Add 90 degrees. Which is what? 315 degrees, right? Check my math on that. So what does that mean? So that means I'm going to start back here at -45 degrees, and I'm going to end at 350. Negative 45 degrees, sorry, 315. I'm sine, my graph is sine, but my dilation factor is negative. So I'm going to go to my starting position, and I'm going to start on the sinusoidal axis, but then I'm going to decrease to the minimum, go back up to the sinusoidal axis, then up to the maximum, and then back down to the sinusoidal axis. Draw my nice smooth curve. And label. Start, comma, sinusoidal axis. Minimum, 45 degrees, add a quarter, minimum, comma, minimum. Add a quarter, comma, sinusoidal axis. Add a quarter, comma, maximum. Add a quarter, comma, sinusoidal axis. Okay. So for each one of these, every time you have a phase shift, the difference is take where you start, right? That's the new piece. You didn't have to do this before. You have to figure out from your phase shift, where do you start? And then you have to take your quarters and add them until you get through one period. And again, today, your period is still going to be either 2 pi or 360. So again, you find your C value, and that's where you start. You take your quarter, which is always your period, divided by 4. That's why it's called a quarter. Period divided by 4. That's the number that you add 4 times to the starting position. 1, 2, 3, and 4. You should be able to check yourself by saying, if I started at negative 45, I'm sorry, if I stopped at 315, what is 315 degrees minus my start, which is negative 45 degrees. So that's 315 degrees plus 45 degrees, and that's 360 degrees, which is the length of my period, right? From start to stop should be your period. And for us today, until tomorrow, your period is either 2 pi in radians or 360 degrees in degree mode. And remember, a period is a horizontal length from start to stop. Okay? So do your homework, and tomorrow I'm going to check both the homework from Tuesday and then the homework from Wednesday. Sinusoidal graphs all have similar shapes. Can you think about what a sinusoidal graph of, if I take sine or cosine and add a full rotation around the unit circle, right? If my starting point is negative 2 pi or my starting point is positive 4 pi, what would that look like? Right? Here's sine, right? Here's sine going from 0 to 2 pi. But what if my phase shift was negative 2 pi? I start here, right? Could you really, if I kept graphing, could you tell the difference? Isn't that crazy? What about cosine? What if I took cosine, which starts at a max, right? If I took cosine, but instead of starting at 0, I started at negative 4 pi. I'm sorry, positive 4 pi. So that would be way over here, right? But if you kept the curve going, wouldn't it? I guess I didn't do a good job at that. But you get the idea. The phase shift, if you move right or left a full rotation and then make the graph continuous, you're not going to be able to tell. So in other words, for this graph, what if I told you this was a cosine graph with a phase shift of positive pi over 2? Or if I said this was a cosine graph with a phase shift of negative pi over 2 and the dilation factor was negative 1. Or this was a sine graph with a phase shift of negative pi and a dilation factor of negative 1. Right? For this one graph, guess how many equations I could write to represent that one graph? A lot, right? And I could write a whole bunch of sine graphs and I could write a whole bunch of cosine graphs. That's an objective that we're going to cover after the quiz. All right. Well, I will hope you have a good rest of your day, and I will see you tomorrow.